This video will focus on 7NS1 of the Georgia Standards of Excellence for Mathematics, Grade 7. In this standard, students will apply and extend previous understandings of addition and subtraction to add and subtract rational numbers, and they will represent these computations on horizontal and vertical number line diagrams. One big idea here involves a new set of numbers called integers. This set of numbers, the positive counting numbers, their opposites, the negative numbers, and zero, describe quantities having both magnitude and direction. While many focus attention on integers before engaging students with rational numbers like -4 5/10 or -1 1/4, it is best to incorporate these negative rational numbers into students' initial work with integers to build students' understanding of how they relate to the integers that surround them. Consider this. Most students will place -1 1/4 on a number line between -1 and 0 instead of between -2 and -1. Using tasks in Unit 1 of the Georgia frameworks, students will, with support and facilitation from the teacher, derive rules that make sense through the contexts used. To build student competence, confidence, and fluency in working with positive rational numbers while introducing operations with negative rational numbers, consider having students make sense of the operations through contextual problems and the use of number lines and manipulatives. For example, here's a simple context about miniature golf. On the first hole at the miniature golf course, I hit 1 under par. On the second hole, I hit 3 under par. And on the third hole, I hit 2 over par. What is my score so far as it relates to par? In golf, par is the predetermined number of strokes or hits that a golfer should require to complete a hole, a round, or a tournament. So how does this look, or how could this look? This simple context offers multiple solution paths for students. For example, students may choose to compare the score for par and the score that they actually get. In this example, for par, I should hit 3, then 4 more, then 3 more on the first 3 holes to get me a score of 10 if I'm hitting par. But I hit less than par on the first 2, and then more than par on the last, which got me to a score of 8. The par score, 3 plus 4 plus 3 equals 10, and my score, 2 plus 1 plus 5 equals 8. So my score is 2 less than par, or 2 under par, or -2. Another way to think about this is to use the over and under par context from the actual problem. So first, I hit 1 under par, then 3 more under par, which takes me to -4, and then I hit 2 over par, which means I have to come back the other way, and I end up again at -2. Some common contexts to use with integers are temperature, altitude, golf, payments and deposits, timelines, both BC and AD, and football gains and losses. The contexts shown here lend themselves nicely to work with rational numbers that aren't integers. Often these contexts make use of decimals rather than fractions. To offer students opportunities to make sense of negative fractions, consider clothesline math, an interactive number line that allows students to build connections and reason about all numbers. You can find more information about clothesline math using the links below this video. Also embedded in this standard is the idea that a number and its opposite have a sum of 0. This idea can be developed spending just a few minutes per day over several days with problem strings like this. If x equals 3, where is 0, and how do you know? Or how about this one? If x equals -5, where is 0, and how do you know? If the opposite of x is negative 4, where is 0? And how do you know? And where is x? And how do you know? If I start at any negative number, how would I get to 0? If I start at any positive number, how would I get to 0? And how do you know? Engaging students in conversations about these ideas help them develop the idea through their understanding of the relationships of numbers on a number line that the sum of a number and its opposite equals 0. In the clips that follow, you'll see students engaging in the hot air balloon task from Unit 1 of the 7th grade Georgia Frameworks. In this task, students use the context of a hot air balloon to discover what it means to add and subtract integers. Blasts of hot air are positive because each blast makes the balloon rise 1 unit. Bags of sand are negative because each bag causes the balloon to descend 1 unit. So, adding a blast of hot air makes the balloon rise. And if we were to take it away, the balloon would sink again. Also, if we were to add a bag of sand, the balloon's altitude would decrease because there's more weight in the balloon. And if we were to take away that bag of sand, the balloon would rise again because there's less weight in the balloon. In the clips that follow, try to answer the following questions as you watch with your team. What do you notice about the students' understanding of addition and subtraction of integers? What misconceptions are being addressed through this context? And how are students gaining confidence as they make sense of these computations?
And then subtracts, go down 7.
And why down 7?
Because it says subtract,
It was what?
add -7 from back to sand
7 bags of sand. Right, nice. So, and what did you end up?
at -3.
The subtract minus parentheses minus turned into an addition sign.
Yeah,
Okay,
it does.
so
Yeah.
that gets confusing, right? Because you're doing subtracting a minus. Go back to what does -9 mean in this balloon thing?
Oh, you're adding sand, right?
Yeah. You're adding sand.
Yeah.
So it's adding. So it would be adding. Like it would be adding sand.
Well, it says
You're subtracting sand.
it says you're subtracting how many bags of sand?
9.
Subtracting 9 bags of sand. What's going to happen to the
It's gonna go
balloon?
up. It's gonna go up.
Yeah, it's gonna go up.
Okay, so if you start at -3
And you go up 9.
and you go up 9, what's that going to be?
12. No. It's 6.
Do you have a number line?
3 plus 9 is 12. No, -3. It's 6.
What about this one? Kind of walk me through this one.
Okay, so you start at -3, and you're adding sand, so you're adding -5. So you're going up
Okay, let's start again. So where does the balloon start again?
-3.
-3, and then
You're going to add
what did you add?
-5
And -5 is 5 what?
back to sand. Oh, so you're going down. You end up at -8.
-8. Does that make sense?
Yes. So
They all have the same answer.
yeah, the same answer.
Why do they have the same answer?
Because if you were like to flip it, or like it's hard to explain, right? Like the 5 minus 2.
5 minus 2 is the same as what?
As 5 plus -2.
5 plus -2. Then they give you the same answer? What about the 7 minus 8?
It still gives you the same answer.
Let's
It's
say
the
that again.
same as 7 plus negative 8.
7 plus negative 8, which is
-1.
negative 1. So that's kind of weird, right?
Yeah.
Why do you think that is?
Because in a way you're kind of taking away something and
Ooh, talk about that a little bit more.
like for the gas you're taking away, you start to take away the gases.
And what happens to the balloon?
It starts to go down.
It starts to go down.
Okay. And on the other ones, what happens?
You would add
You
the
would add
sand,
the sand and it would
still go down.
And it still goes down, right?
If it was like this is a negative, if it was a positive plus positive, I'll say if it was 1 plus 1, it would be 2, which is still positive. If this was like -1 plus -1, it would be -2, which would still be a negative
Oh, so the answer would have the same
integer.
sign, right? It's the same sign. Okay. How could you prove that? Maybe using the balloon number line.
Using the number line,
Yeah, with the balloon.
like with gas and sand.
Yeah, yeah.
So I could say if I had one bag of gas in the balloon and I added another bag of gas, it would go up higher. It would still say positive. It wouldn't go down to like negative. It wouldn't go lower. It would go higher. Same thing with the sand.
So
Pause the video here and take some time to discuss what you noticed with your team. How was this context helpful to the students? What might the benefit be for students to tackle this task without ever hearing an integer rule for addition and subtraction? For additional support and resources, please visit GeorgiaStandards.Org, where you can access additional tasks, intervention materials, and more.